So here we'll be looking at the Python implementation of the same birthday paradox problem which we looked just now. So what we'll do is we'll do a Python console setup. We'll be working on a Google Colab notebook. So for that, for accessing a Python notebook, you just have to Google Colab and click on the first link. And when you do that, you will be able to self login your Gmail ID and just click on a new notebook. So when you do that, you get a new Python notebook where you can run your Python codes. So this is how it is going to look like. So now to perform the question, so our question here was, what is the minimum number of people required in a room such that there is at least a 0.5 probability that at least two of them would have the same birth date. Now to do so, what we do, we had already come up with an expression which was permutation of 365n should be divided by 365 raised to power n should be less than 0.5. Now in Python, to calculate the permutation between two numbers, what we do is we import a certain module. So modules in Python is nothing but they are a set of functions. So what we'll be importing here to calculate the permutations of a number is called the math module. So we simply do import math, and if we, let's say we first import that, then we use the dir command, which is like a directory command for the math module to look at what all we have inside the math module. So if we look at the list here, we'll see a function called perm. So let us try to calculate. Let's say we want to calculate the permutation of 5 objects taken 2 at a time, which if you remember how we calculated, it will be 5 into 4 is equal to 20. Basically 5 is the number of ways to select the first item, and once we have done that, we are left with 4 items, and there will be 4 ways to select the second item. This could also be calculated using the formula which we saw, which was n factorial divided by n minus r factorial. So in this case, it would be 5 factorial divided by 5 minus 2 factorial, which is 120 divided by 6, which is 20. So once again, let us check if we get the correct answer here. Oh, so we had to write the function name here, math.perm permutation, which is, and we get the required output here is 20. Now we have already come up with this particular expression, so we'll just copy it from here. So right now we have this particular combination here, which we have to, this equation here, which we have to implement in Python. So we first define a function func n, and let us say inside the function we are returning the above value, which is math.perm 365n divided by 365 double asterisk n. So if you remember, double asterisk in Python is used to calculate the power. Now once we have done that, let us try to run this particular function for all the values of n from 2 to 50. So let us say for I in range, or let's say we call it n itself, for n in range to start 50. So the first parameter here is the starting value, which is 2. 50 is because we are running till n equal to 50, and 1 is the difference between two consecutive values. So we are running it like for every integer, so 2, 3, 4 and so on. And what we are checking here, if, let's call this funcval, if funcval n is less than 0.5, we return the value. So we just print the value of n. Also we break the loop. So this break keyword is used to exit the loop for when a certain condition is met. So in this case, that certain condition is when the function value at n is less than 0.5. Now if we run the loop, we get the output here as 23, which is the required value of n. if you also want to see the value of the expression, that is 0.49, which is less than 0.5, and therefore the required condition is met here and we get our required value of n as 23. Now another way to do so was in Excel, like we explained in our in the same session here. So we use the permute function here, and we use 365, and let us say the value of n right now, let us say, is here, and we divide it by 365 raised to power again n. So this is the value of n right now. Right now it's 0, that's why it is coming out to be 1, because permutation of 365 with 0 is 1, and 365 raised to power 0 is also 1, so we get it as 1. Now if we keep changing it, we'll see different values of n here changing. And now if we use the hit and trial method, so obviously when we keep on increasing the value of n here, this value keeps on decreasing, but since we have to keep it below 0.5, we take a larger value. Let's say we take 25, we get 0.43, so this is way lower than 0.5. Now we keep decreasing the value of n, and we notice that at 23 it's just slightly less than 0.5, and at 22 it actually is above 0.5. So the required value of n should be 23, as we want this value to be less than 0.5, and we need the minimum value of n, which will be 23 here. So these are the two ways in which we could have obtained this value of n using both the Python and the Excel method here.